So let's start with the introduction to hypothesis testing. And our main goal here, or our main objective, is to identify null and also alternative hypothesis. So we are going to state a null hypothesis and an alternative hypothesis. Then we are going to identify what we mean by type 1 and type 2 errors, and also interpret the level of significance. So normally it doesn't matter what kind of hypothesis testing we are doing, whether it's a parametric or non-parametric. We always have to start with stating the claim. The claim will be the null hypothesis. Alternative hypothesis will always go against the claim, against the null. Now, type 1, type 2 error means we reject the true and or we accept the false. So those we're going to explain what. Now we know when we are doing hypothesis testing, when we making a conclusion, we never mention alternative tests because again, we use a sample data too. So normally either we accept or reject or fail to reject or accept the claim. So normally we will say whether we reject the null hypothesis or fail to reject null hypothesis. So if the null hypothesis is false, then we have to reject it. So if we accept it, then that's null. Or if it's good, if it's true, and the true statement, but we reject it, then we also have another error. So those are the type 1, type 2 error. We shall go through what we mean. Then also we're going to determine whether to use, so we have three ways. Either we can do one tail, greater or lesser, or we can do two tail start test and also find the P. So the level of significance. So this is more or less like introduction to hypothesis testing. Normally we say at least it's first step. First step, we state the claim, both the null and alternative hypothesis. Then we are going to find the test statistics. Before that, we can find the critical value. We can only know the critical value if we have at least the alpha value, and also depend on the type of hypothesis testing we are doing. And again, we'll go through that, but we get the critical value, then we get the test statistics. Then if one is greater or lesser than other, it may fall under the rejection region or acceptance region, not rejection region. Now, if we are doing that step, then we don't need a p-value. If we are using the p-value, then we normally will say that if the p-value is less than the level of significance, by default, most of the time we set it to 0.05. If it's greater than 0.05, then we have to accept the HO, the null hypothesis. If the p-value is very small and lesser than the level of significance, then we are going to reject the null. So normally we accept the null or fail to reject the null when the p-value is big, at least bigger than the level of significance, the alpha value. Yeah. So let's go through the steps here. First of all, we will go through what is hypothesis test and the definition. Here we say a process that uses sample statistics to test a claim about the value of a population parameter. So we'll say that hypothesis test is inferential statistics. We use a sample to test the whole population or to make a decision on the population. So for example, here we say an automobile manufacturer advises that its new hybrid car has a mean mileage of 50 miles per gallon. Now, to test this claim, we are going to take a sample. So a sample will be taken. If the sample mean differs enough from the advertising mean, then we can decide that the advertisement is wrong. So in this section, we are going to reject than the claim, which is the null hypothesis. So that will take us to what we mean by stat hypothesis. So a statistical hypothesis is a statement or a claim about a population parameter, So we need a pair of hypotheses, as we said earlier. One that will represent the claim, which is the null hypothesis, and the other will always go against the claim. Here we say it's complement. So if the null hypothesis or the claim said is equal to 10, then to go against it, we cannot say greater than 10, because it can be greater than 10, it can be less than 10. So we are going to say not equal to 10. So then normally this would be the two-way test or two-tail. Then when we say it's greater, then the other should be lesser or equal. So both the claim, or let's say the null hypothesis, and the alternative hypothesis cannot agree. They always have to go against each other. So that's what we are saying here. When one of these hypotheses is false, the other must be true. So this is the null hypothesis. The symbols we can use here: less than equal, equal, or greater and equal. If that's the case, and also we are going to represent it as most textbook does, HO will be the null hypothesis. Then the alternative hypothesis always will go against the null. So if it's less than equal, then it should be greater. If it's equal, then it's not equal. If it's greater and equal, then it should be lesser. So always go against it. So must be true if HO is false. Complement of HO is HA. If HA is false, HO then must be true. The other way around also. And also here we are going to use the symbol HA to represent alternative hypothesis. We are going to pronounce it as H sub A. HO will be H naught. So next, stating hypothesis. Here we say to write a null and alternative hypothesis, we translate the claim made about the population parameter from the verbal statement to a mathematical statement. So we can write its complement. So for example, if HO is the mean, this will be our mean, population mean. If population mean is less than or equal to K, then HA means population mean will be greater than K. If the mean, population mean is greater or equal to K for HO or H naught, then H sub A will be the population mean is less than K. So always opposite. And if the population mean is equal to K for H naught, then H sub A will be not equal. So here we say, regardless of which pair of hypotheses you use, you always assume the mu equal to K, then examine the sampling distribution on the basis of this assumption. So let's see some example now. So the first example we have here, they say we should write a claim as a mathematical sentence. Then we state the null and also the alternative hypothesis and identify which represent the claim. So a question given, a university publicized that the proportion of a student who graduated in 4 years is 82%. And so this is a claim. The university publicized that the proportion of students who graduate in 4 years is 80. So we have the HO and HA. Again, anything HO will say, HA will go against it. So that's the claim here. So here, proportion, so P equal to 0.82. Okay, so this means for a few seconds. If no question, let's keep going. Okay, second question said the water faucet manufacturer announces that the mean flow rate of certain type of faucet is less than 2.5 gallons per minute, less than 2.4. So again, we have the HO to be the opposite of HA. So it will be greater than or equal if it's less. So here we say HO or H naught, the mu is greater than or equal to 2.5 gallons per minute. That's the complement of HA. So this is inequality condition, the cream. And as we said earlier, somebody may say, okay, why we don't say that the HO, the mu is less than 2.5 because that is the cream. Then the HA will be greater than or equal to 2.5. To answer this question, we will go back to beginning here. You can see that if you look the HA equality, if it's greater, it's greater. If it's less, it's less. Then HO is where less than equal, greater than equal. So that's how this starts. That's the whole concept here. Yeah. So HA never include equal. So that's why here we have this result. Now, let's see another example. Here we say cereal company advertises that the mean weight of a content of its 20-ounce size cereal box, okay, is more than 20 ounces. See, there's no equality here also. So you see that the HA will be, H sub A will be mu greater than 20 ounces. So this, which means the null hypothesis will be what? Less than or equal, which will be complement of HA. Okay, so that will take us, so we finish with the first objective, how to state the HO and HA, and also their meaning. Let's wait for a few seconds if any question on that. Okay, so that will take us to the next topic, types of errors. Here we say no matter which hypothesis represent the claim, always we should begin the hypothesis test assuming that equality condition in the null hypothesis is true. So we can see that in the null hypothesis, that's where we always have the equality. And we always should assume that is true. So at the end of the test, one of the two decisions will be made. As we said earlier, either we reject the null hypothesis or we're going to fail to reject the null hypothesis. Again, anytime we are interpreting our results or our findings, we never say, we don't mention HA. We don't say we accept HA or fail to accept HA alternative. We always null hypothesis. Yeah. So now let's see. One example I give is that you go to the court. They may find you not guilty, but that doesn't mean you didn't do it. Maybe you play your smart game, or you are lucky. There's no enough evidence. Because as we know, the law of court, I say the law of the court, even they know you did it, but if they can't prove, they can't have a solid evidence, they have to leave you alone. So that's why, again, we focus on null, the claim. We know the claim always. Yeah. Okay, so this will lead us to two types of error. As we said earlier, you reject something that is good, or you accept something that is bad. Normally in the medical field, actually not in some other fields. And the second one, if you reject something that is good, it doesn't affect you too much, then you accept what is bad. So one is bad, but one is very serious. So that's what we have here. Type 1 error means type 1 error occurs if the null hypothesis is rejected when it's true. So type 1 error is not that bad in terms of, let's say, medical field or something. Maybe it will be bad, but let's see type 2 error. Type 2 error said the thing is bad, especially let's say it's a poison and you accept it, or you drink a poison there. So we may always say that type 2 error is more dangerous. But again, depends on the scenario. But in general, that's what we say. So actually, let's look at the table here. The table explains everything. Type 1 error means actual truth of the HO. HO is true. So that's the actual truth. The HO is true, but decision we make, we reject it. So type 1 error occurs when we reject the true HO. Type 2 error, the actual truth is that HO is false, it's not good. So if HO is not good, but then we need to reject it, but we do not reject HO, so we accept it. So that's the second option. Type 2 error occurs if the null hypothesis is not rejected when it is false. So let's see the example here. Actually, this is a medical example now. They say USDA limit for salmonella contamination for chicken is 20%. The meat inspector report that the chicken produces by a company exceed the USDA limit. You perform hypothesis tests to determine whether the meat inspector claim is true. When will a type 1 or type 2 error occur? Which is more serious? Okay, this one is type 2 is serious because the year now is a contamination. So if it's contaminated, then we take it. Well, it's good we didn't take it. It's still bad, but not too bad. But let's see what the result they will give us here. So let P represent the proportion of chicken that is contaminated. So the question said greater than 0.2. So P should be less than or equal to 0.2. So now we have our scale from 0.16 to 0.24. Then we can see where the 0.2 is. We say if the chicken exceed the USDA limit, which means if P is greater than 0.20, chicken meet the USDA limit, it means it's less than or equal to 0.20. So that's our HO and HO. Now the second one question, they said which one will be serious? Yeah, we said type 2 error will be serious. Then let's see if it's true. Type 2 error means, as we saw it earlier, the thing is not good, but we like it. So HO is greater. It's not good, greater than 0.2. Contamination is too high. So we're supposed to reject it, but we accepted it. And let's see type 1 error is rejecting HO when it's true. It's okay. The actual proportion of contaminated chicken is less than or equal to, but you decided to reject HO. But type 2 is failing to reject HO when it is false. The actual proportion of contaminated chicken is greater than 0.2, but you do not reject HO. So let's see the final result. With type 1 error, you might create a health scare. Yeah, that's true. And also you may hurt the sales of chicken producers who were actually meeting the USDA, but you say it's not good. So economically, it's not good for them. But with type 2 error, you could be allowing a chicken that exceeded your USDA contamination limit to be sold to consumers. And that type 2 error could result in sickness or even a death. So it's better than the company lose money than to waste human being life. Yeah, so type 2 is more dangerous. So next we go to what we call the level of significance. So most of every hypothesis testing, type 1, type 2 error will come, HO and HA will come, then also level of significance also may come. So we say a level of significance, this will be your maximum allowable probability of making a type 1 error. So that's why most of the time we say 95% confidence. So it will be default, we say 0.05. There's a chance of 0.05 that I may have. That's why we say if we get a p-value and it's less than the level of significance, then we are going to reject HO. If it's greater, then we are going to accept HO. Let's wait for a few seconds if it's okay. So type 2 error, as we said earlier, HO is not good, but you accepted it. Type 1 error, HO is good, but you rejected it. So the level of significance focus on your maximum allowable probability of making type 1 error. Now, we use the symbol alpha. Most textbooks all use the symbol alpha. So by setting the level of significance at a small value, we are saying that you want the probability of rejecting the true null hypothesis to be small. We can set it to 0.15, 15%. That's kind of high. So by default, most of the time, 0.05. So example can be the commonly used level of significance. Sometimes we may see 0.10, but as we say, 0.05 is very common. Even the software application, most of the time you see the default value, 95% confidence. So what we call type 2 error is the beta error. And we may go through a calculation to find it also. So let's see the next step to state the test. So here we say a statistical test after stating the null and also alternative hypothesis, and also we specify the level of significance. A random sample is taken from population, and the sample statistics are calculated, or we say the test statistics is calculated. Also, with the level of significance, and depending on the type of test, we can also find a critical value. If we don't want to use the p-value to reject or accept HO, we can use the test statistics and the critical value to do it. So that's what we say. The statistic that is compared with the parameter in the null hypothesis is called the test statistics. And each test have different formula. For example, t-test, z-test, ANOVA, different. Actually, ANOVA is the F value, so different formulas. So these are the symbols that we may see in this section: population parameters, test statistics, and also the standardized test statistics. We talk about the z-test, t, and chi-square, and also z4. So this section talk about if the sample is large. Normally we consider a large sample if it's 30 or more. If the sample is less than 30, we say it's a small sample. Yeah. So that will lead us to the concept of p-value or probability value. So the probability, if the null hypothesis is true, of obtaining a sample statistics with a value as extreme or more extreme than the one determined from the sample data. As we mentioned earlier, the p-value always, if it's smaller than the level of significance, then we are going to reject the null, the HO. If it's greater, then we are always going to accept the HO. So depending on the nature of the test here also. The nature of the test, we have three types of hypothesis testing: the left tail, right tail, and two tail. Two tail normally equal or not equal, so you're using both sides. So that's why when we get the p and the p-value, if it's a two-tail test, we multiply by 2 first. So the type of test depends on the region of the sampling distribution that favor rejection of HO also. The region is indicated by alternative hypothesis. So this example of a left tail test. The left tail test means HO must be greater than or equal to K. K can be any value. Then this means HA is less than K. So that's why we say it's left tail, less than. Then when it's greater, so yeah, this will be. So we're going to, the line here will give us the value, the critical value to differentiate the rejection rate. Normally in this textbook, they use the brown area to be the rejection region. We can find this by finding, again, the critical value. Before doing that, we have to convert all these values to Z. If we are doing Z-test, we'll convert it. Then we have an right tail, then it will go to the right because we can see the HA, the mu is greater than K. So whatever value we get in the blue section, we are going to reject the HO because it's true. Mu is greater than the K. The brown area is less than or equal to K. So that will be not to reject HO, accept HO. Here we can see greater than and equal to K. So the brown area here also the same thing. We accept the K or fail to reject K. So that's the whole concept here. If no question, let's keep going. So two-tail, we're going to see left and right. So we get a K. Same value, but one will be negative, one will be positive. So that's the test that it takes. Positive value and negative value. So we say the P is twice the area to the right of the positive test statistics. Okay, so now let's see an example to identify the nature of a test. They say for each claim, we should state the HO and HA. Then we should determine whether the hypothesis test is a left tail, right tail, or two tail. Then possible sketch your normal sample distribution and shade the area for the p-value. A university publicized that the proportion of its students who graduated in 4 years is 82%. So the keyword here is, which means equal. So we are going to have two tail here. So let's see the HO first. Yeah. So is equal. So P equal to 0.82. HO will say not equal. So if we have to draw this, we get two tail. Half p-value area, half. So the blue areas will be failed to, reject HO. The brown area will be failed to reject HO because it's equal from negative Z to positive Z. Let's see another example, if no question. The next example, they say a water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons. So here the keyword is less. So that will go to the HA. So mu is less than 2.5. Then HO will be greater or equal to 2.5. So this is left tail. Let's see, left tail. And this is what we get. So the blue area again is the rejection of HO. Let's see one more example. A cereal company advertises that the mean weight of a content of its 20-ounce size cereal boxes is more than 20 ounces, more than. So HO will be more than 20 ounces. If HA is more than 20 ounces, then HO will be less than or equal to 20 ounces. So this will be right tail because HA we say is greater than 20 ounces. So it's a right tail. So the blue area will be failed to reject. we accepted the HA, but normally we say fail to reject or reject HA. I mean, look, I'm saying opposite. This section, well, again, we don't use the HA, we use HO. So this blue area will be, we rejected HO. Brown area is failed to reject because that's what they said here. The mu, HO means the mu is less than or equal to 20. So from there to the left will be the cream for HO. The blue area means we rejected HO. Brown area is less or equal, fail to reject. Okay, let's keep going. Okay, so that's actually here they are teaching us how to make the decision now. So compare the p-value with alpha. If p, as we said earlier, if the p-value is less than or equal to alpha, then we are going to reject HO. If p is greater than alpha, then we fail to reject HO. And also here we can see that based on here, mu is less than or equal to 20 ounce. So if you fall in the blue here, we are going to reject HO. If you fall in the brown area, we fail to reject HO. And same to the previous one too. Greater than or equal, so the brown area. Fail to reject HO, less than. So blue area will be fail, reject HO. Blue area is to reject HO. Yeah. So that's the decision here also. We can put it in English. There's enough evidence to reject H or reject the cream. Cream is the HO. Or here we can say there is not enough evidence to reject the HO if we fail to reject HO. Also here we say there's enough evidence to support the cream. And also there is not enough evidence to support the claim. So here we are going to see example how to interpret a decision. Here they say we perform hypothesis testing for the following claim. How should you interpret your decision if you reject HO and if you fail to reject HO? So a claim said the university publicized that the proportion of its students who graduate in 4 years is 82%. It means equal. So two-way. So here we can claim if you reject HO, then we are going to say there's sufficient evidence to indicate that the university claim is false. Because if I reject HO, the claim, it means the claim is false. Or if we fail to reject HO, which means it's true, it's not. So you should conclude there is insufficient evidence. There's not enough evidence to indicate that the university claim is false. The next one, we have a consumer report states that the mean stopping distance on the dry surface for Honda Civic is less than 136 feet. It's less. So the claim is represented by HA because less. So HO, we say that the mean stopping distance is greater than or equal to 136. So if we reject HO, then we can say there's enough evidence to support the consumer report claim. Otherwise, if we fail to reject, then consumer claim is false. So if you fail to reject, we can conclude there's not enough evidence to support the consumer report claim. With a few seconds, if it's okay. And I think that should be the conclude. Oh, not yet. Okay. So the next will be the steps for hypothesis testing. This is just a general steps. So as we said earlier, first thing we need to do is to state our claim. Then we should go against the state what will go against the claim. So as we said earlier, the claim is always complement. It's always complement. So wait for a few seconds if it's okay. So let's see example if they have one here for us. Or they don't have it. But as we said, HO always HO will go against complement of HO. So the next step is to specify the level of significance. Most of the time it will be given to us. If it's not given, then we assume it default 0.05. So if we know the level of significance, we can determine the standardized sampling distribution and draw its graph. Then after that, we calculate the test statistics. Then we can sketch. Then we find the p-value using the following decision rule. If the p-value is less than or equal to the level of significance, then if it's, well, first of all, if it's no, then we are going to fail to reject HO, because that means the p-value is greater than the alpha or level of significance, so we fail to reject. But if it's yes, then we are going to reject HO. Then we have to write a statement to interpret the decision in the context of the original claim. So that will be the summary of these lectures. So again, these lectures give us the idea when we are making or we are doing hypothesis testing, what components or elements we have to, or the steps also we have to follow, and what they mean each one. So as you said, and it depends on the type of tests, but the process, the steps are most the same. State your HO, state your HA. If we can find a critical value based on the alpha value given to you or degree of freedom, if we are doing t-tests, etc., then we find the test statistics. We can compare the critical value with the test statistics, and that can leave us to either to fail to reject HO or reject HO. Or if we are not using the critical value, we can use the p-value. If the p-value we find is less than the alpha, then we are going to reject HO. If it's greater than alpha equal, then we are going to fail to reject HO. So normally if the p-value is very big, we are going to accept HO. Or best way to interpret it, we fail to reject HO. Yeah. Okay, so and also we went through the type 1, type 2 error. When you accept something that is not good, or you reject something that is good. That's the claim is true or not true. Claim is true, but you rejected it. Claim is false, but you accepted it. Okay, so that will be the conclusion of these lectures. Let's wait for a few seconds. If no question, stop the recording there.